hybrid mixing and latency, analog gear, ADDA converters, interface. In this video, I'm gonna show you how to calculate your ADDA trip when you go out from your interface into your outboard and back into your interface or converter, and how to compensate for the hardware insert latency. Let's get to it. Hello everyone, welcome back to MixbusTv. Hope you're having a great day. Before we start, check the info box down below for my mixing courses on ProMix Academy, special discounts and offers on plugins, and if you want to become a MixbusTv member, help the channel, but most important, access to exclusive content like exclusive videos, members only posts, live chats, Pro Tools sessions and files to download, and also mix consultations via email and Skype with me. Click the join button down below. Let's get to the video. When we use analog gear for mixing, so we go out from our interface or converter into our analog gear and then back into the DAW, there is what is called the ADDA round trip. The signal will go back into your DAW with few samples of latency, of delay. This will always cause a problem for syncing, and also if you use hardware for parallel channels. The amount of latency is different for every system because it depends on many factors. For example, how powerful your computer is, the drivers of your interface or ADDA, and also what sample rate you work with. And this is important because the process that I'm about to show you, you need to do it for every sample rate you work out, because it will change every time you change your sample rate. So in my rig, I have two different converters, my Motu and my SSL. So I will need to calculate the hardware insert latency for both because it's going to be different. The SSL is connected to the Motu via ADDA. So let's take a look at the Pro Tools project that I created to calculate first and then compensate for the hardware insert. I will upload this Pro Tools template and make it available for download for MixbusTv members. So you can use this one if you want to do the same. All right, so as you can see here, I have one audio track, which is direct, and another audio track, which is the ADDA trip. I open a click track with a simple click instrument, stock Pro Tools. The first thing I'm gonna do, I'm gonna record the direct click. Now I'm gonna send this track to bus 3, and I'm gonna record it here, input bus 3, in our ADDA trip, with the hardware insert on. The recorded track will be late and we'll calculate how much is the latency we have. All right, let's take a look. Let's zoom in and you can see clearly it's late, right? This is normal, this is what we want. So we just grab the cursor and select this section. This is our delay. If we open the counter, we can see here length 81. This is how many samples of latency we have. If I select another length, you can see length 43. So that's how you see it. So we said, just let's double check. We have 81. At this point, we need to calculate how many milliseconds 81 samples are at 44.1. Okay, because it will change if we work at 48, 88, 96. Because in Pro Tools, the way we compensate is by opening the I/O tab and going here, the last tab, hardware insert delay. You can see we have all our channels, and here you can input your value, but it's in milliseconds. So we cannot input the value in samples. We need to convert samples to milliseconds, and it changes for every sample rate. But the good news is it's pretty simple. We just grab a calculator and we divide 81 by 44.1. And that's our latency in milliseconds, 1.83. We input this and we copy it for all our first 8 channels because that's the latency of our Motu interface. The SSL is going to be different. I'm not doing channel 1 and 2 because those are out to my monitors. All right. Now we set the compensation and we record again. And this time we should be aligned. The insert is always in. And let's take a look. There you go, perfectly aligned, all right? So now we do exactly the same process for the SSL. And how we do it, simply we select one of the hardware that is connected to the SSL. So channel 9 and on. In this case, I'm gonna use the Pultec West Audio because I can put it in bypass. We record again because we didn't put any hardware latency compensation in the next channels. Let's take a look. And as you can see, we probably are further away from what we have with the Motu. Let's make sure we are precise. In this case, we are. It's probably 111. We'll do an actual audio test for this because you can see it changes a little bit, the waveform. So it could be 110 and it could be 111. I would probably say 110. And we do 110 by 44 divided by 44.1 and we have 2.49. So let's see if that works. From channel 9, 2.49 milliseconds. And we copy it on all the other channels. Click OK and re-record and see if we're there. Let's take a look. And I would say probably we are better off with a little more. Because we probably are one sample off. See? So it was actually 111, I would say. So let's do that again. 111 divided by 44.1 and we are 2.51. Let's try that. And I remind you, this is for 44.1. You have to do this for all the other sample rates you work at. All right, let's re-record again. Let's take a look now. And we are right there. You can see now we are perfectly aligned. So be precise with this because when you open an instrument, when you use hardware insert for parallel channels, you will have phase problems, okay? And just to make sure, I want to test by ear with audio material. I'm gonna grab this drum, send it to a bus and put my successor on it and just see if I hear any phase issue. All right, this is correct, okay? All you hear is a rise in volume and that's all you want to hear. If you have any phase issue, it will not, especially because this unit now is bypassed. So you will hear phase problem. It would be very noticeable. Let me show it to you. All I have to do is just insert a simple delay, a few milliseconds, and I will use mod delay, so no modulation, no filters, no anything. And if I just insert, I'm gonna link them. Even 1 millisecond of delay. That's what you're gonna hear. This is what you're gonna hear when you parallel something and your ADDA trip is not correct. Even 1 millisecond causes this, even 0.1 milliseconds. All right, without it and with our insert in the chain, all right, everything is perfect. Now let's test the SSL. We said we had the Pultec in it, and I have to remove it from this insert here to make it work. Make active. All right. No problem, no phase issue, no phasey sound. So we are perfectly aligned with both the Motu and the SSL when using hardware insert. And this is it for this video. I hope it was useful. I hope you liked it. And if you did, please don't forget to leave a like. If you have any questions, as usual, leave it in the comment down below. Also leave your questions for the rapid fire Q&A. We're gonna go back to the next batch of questions very soon. Check the info box down below before you leave and all the perks of becoming a MixbusTv member by clicking the join button. Thank you for watching. Subscribe if you haven't already. See you next time.